function operations. All right, we know some basic operations. We know we have addition, subtraction, multiplication, and division. And that's exactly what we're going to be doing with functions, f of x and g of x. So let f of x and g of x be functions. We can add them together. We can subtract them. We can multiply them. We can divide them. There's some other stuff we can do with them too, but we're going to do that a little bit later. All right, so if we add them, it's more a notational thing. We write down adding f plus g of x together as exactly that, f plus g of x. So it's not like we're adding the letters f and g and multiplying by x. This is function notation to represent the sum of f of x and g of x. This actually means f of x plus g of x. So we have to get used to knowing that notation. Subtracting, very similar, f minus g of x. That just means we're going to take g of x and subtract it from f of x. Multiplying, f times g of x. We're just taking f of x, multiplying it by g of x. And dividing f over g of x. That would look like f of x divided by g of x. Except there's one function we cannot divide by, and that would be 0. The constant function is 0, so we want to say that g of x cannot equal 0 if we're talking about division of functions. Otherwise, we'd have something undefined. Let's do some examples of this. Let's let f of x be 3x plus 8, starting off pretty basic. And let's let g of x be 2x minus 12. Let's see what these function operations would look like in practice. F plus g of x. Well, I know we're just taking f of x and adding it to g of x. We're essentially going to do that. Here's f of x, and here's g of x. But there's no reason, we don't need the parentheses here. We have 3x plus 8 plus the quantity 2x minus 12. We don't really need parentheses. We can just combine all those like terms. 3x plus 2x is 5x, and 8 minus 12 would be negative 4. Now we have to think about any time we're manipulating these functions what our domain comes out to be. I want to think about what we're doing. We have a linear function here, f of x, 3x plus 8. Its domain is unrestricted. G of x here is another linear function, 2x minus 12. Its domain is unrestricted. We added them together. We got yet another linear function. Its domain is negative infinity to infinity. So what that tells us, we took two lines, we added them together, we got a third line. It didn't really affect the domain too much. Let's see what happens when we subtract them. We have, here's f of x minus g of x. This time we have to be careful, we're subtracting a binomial, so we're going to subtract each term. We want to distribute that minus 1 out here. This ends up being 3x plus 8 minus 2x plus 12. When we simplify, we get 3x minus 2x is just x, 8 plus 12 is 20. Turns out when we subtracted one line from another line, we ended up with a third linear function, and again, our domain is unrestricted, negative infinity to infinity. I wonder if our domain's ever actually going to change. Well, we'll see what happens. So yeah, so we added two lines, got a third line, subtracted a line from a line, got a third line. I wonder what happens if we multiply two lines. F times g of x. We're going to take 3x plus 8, multiply it with 2x minus 12. We know how to do this. We know this is 6x squared. Let's see, 3x times negative 12, negative 36x. 8 times 2x is plus 16x. 8 times negative 12 is negative 96. We want to combine our like terms. We get 6x squared minus 20x minus 96. We took a line, multiplied it with another line, and we ended up with a quadratic. We have this x squared function here, so that should kind of make sense, since x times x is giving us that x squared. But still, our domain is unrestricted. We didn't do anything weird to the domain, negative infinity to infinity. There's still no issues here. We can plug in whatever we want to our final function, so our domain is negative infinity to infinity. Let's try f over g of x, f divided by g of x. Or, let's see, f of x divided by g of x. Here's f of x in our numerator. g of x in our denominator, 2x minus 12. And there's not much we can simplify here. I notice there's a 2x minus 12 in our denominator. I can factor out a 2. We're left with x minus 6 there. Still nothing can be simplified. There's no common factor in every single term here. So we're actually done. This is our quotient, 3x plus 8 over 2 times the quantity x minus 6. Except you might be realizing there's now a domain issue. We took a line, divided it by another line. We ended up with a function known as a rational function. We're going to learn a lot more about rational functions in chapter 9, I believe. So we don't really have to worry too much about graphing this guy, but we do want to recognize that our domain now has a problem. We can't plug in x equals 6, otherwise we'll get division by 0, which we know is undefined. So we know that x is not allowed to be 6. In interval notation, that's negative infinity up to 6, union 6 to infinity. So we have to be careful with function operations. Sometimes it affects our domain. Sometimes there ends up being these numbers that we are not allowed to plug in. Let's just do one more example. We'll see. This might get a little bit how complicated we could get. Let's see. Let's try f of x equals x squared minus 1, and g of x equals just x plus 1. And let's try g over f this time. Let's see what kind of stuff can happen when we divide. G of x was x plus 1. F of x was x squared minus 1. If you notice that denominator, x squared minus 1, is a difference of squares. So you can factor that into x plus 1, x minus 1. And you notice we do have a common factor. We have an x plus 1 in the numerator, an x plus 1 in the denominator. We can cancel those out. We're left with 1 over x minus 1. This 1 over x minus 1 is our simplified function. That is our simplified quotient, g over f of x. But you notice we actually have a couple of domain problems now. X was not allowed to be negative 1 from this step back here, otherwise we'd have division by 0 over here. And x is also not allowed to be 1, otherwise we'd have division by 0 over here. So even though we were allowed to cancel out that common factor, we can't forget about the fact that it used to be there. It's coming from this quotient, g over f. So we have to make sure that when we write our domain, we cannot include negative 1 or 1 in our domain. So what that would look like in interval notation, it's a little crazy. Let's see, negative infinity all the way up to negative 1, and then everything between negative 1 and 1, and then everything after 1. So this is basically, it's easier to say than it is to write interval notation, basically all real numbers except negative 1 and 1. So our interval notation is broken up like that. But yeah, that's function operations.